Welcome back to the lecture series of communication system. In this lecture, I am going to discuss about the time division multiplexing. In short, it is called TDM. So basically, time division multiplexing, there are two types of multiplexing. One is the frequency division, another is the time division. So here we discuss about the time division multiplexing or TDM. So in TDM, each information signal is allowed to use all available bandwidth at a particular time. In theory, it is possible to divide the bandwidth or the time among the user of a channel. Continuous variable signals such as analog are not well adapted to TDM because the signal is present all the time, but digital signal we are able to we can easily adopt time division multiplexing. So in time division multiplexing, signal is accomplished by divide available transmission time on a medium among user. Digital signaling is used exclusively in time division multiplexing, come in the two basic forms, synchronous and statistical. It means this time division multiplexing exclusively used in digital signaling. And there are two types of time division. One is the synchronous time division and second is statistical or asynchronous time division. See this particular diagram of our time division multiplexing, a digital process used when data rate capacity of the transmission medium is greater than data required by sending and receiving device. It means if the capacity of a transmission medium is greater than data required by sending and receiving device, then we use time division multiplexing. See here, device 1, 2, 3, 4, and the time slot 4 seconds is allocated to each device, and there are a gap between two, device 1 and device 2, just for the synchronization. For example, 5 and 6, there is the gap of generally in a one time slot, that is called a guard band. Just that this particular is used for the synchronization purpose. And we see here we allow a 4-second time to each device. So device 1 use all the available bandwidth for 4 seconds, then device 2, then device 3, and so on. See here the time division multiplexing. In this diagram we show 1, 2, 3, 4. There are the 4 computers that have some data to transmit, and there are in the between we show the data flow. So first, in the first time slot of the one computer is combined with the first time slot of the second, then third, then fourth. So this you see here, first, second, third, fourth. Then in the second interval, again the second time slot of the first, second time slot of the second time slot of the third, second time slot of the fourth. Again it will combine. In similarly in the third case, third time slot of the first, third time slot of the second, third time slot of the third time slot of the fourth, again combined. So these are the basically data flow. At the transmitter in, it multiplex, in the receiver it deep multiplex. Both are the synchronized, so the information from one is transferred to the computer 1, information from 2 to transfer with computer 2, or it to their designated addresses. So these are the basically working of a time division multiplexing. It is a digital multiplexing technique and it used to combine a data. Synchronous multiplexer allocate exactly the same time slot to each device, regardless if they don't want to transmit. Then it's the frame. Time slot are grouped into the frame. A frame consists of one complete cycle of the time slot. For example, it is a frame. So first frames of the first, then the first frame of the second, first frame of the third, first frame of the fourth. Similarly, second frame of the first, second, third, fourth. In that way we allocated these time slots. These are the basically TDM frame. See here how it will work. So you see here A3, B3, C3 is combined, A2, B2 and C2. There is no C2, so its time slot is allocated to the C, but they are not utilized, so it will blank. Similarly, in the second case, time slot is also allocated to the B, but it's A1, A utilized its time slot, so it is A1. B is not utilized, so B is blank. It means there is a wastage of the time slot, but time slot is equally allocated, divided among the users. And each time slot at least you transfer one data, and we combine this, must combine the data and can convert it into the one frame. This one frame 1 consists of the 3 frames, and each 3 frame is belongs to the each time slot, and that time slot is belongs to a different subscriber, in this case ABC. Then the synchronous time, see here 1, 2, 3, 4, there are the 4 again, 4 computer. Then there is the multiplexer, and see here D have the data and rest 3 is idle. So if it is idle, it is represented by the 0, data is represented by D. See here D 0 0 0, D 0 0 0. But it means the time slot is allocated to all the computer, whether it is idle or they transmit something. If they idle, it means the 0 data is transmitted. If they transfer something, then some data will transfer. So that is clear in this particular case. All the 3 have the no data, so they idle in this time. So it have the 0, 1 have the data, but the slot is allocated to all. That is the case of a synchronous time division multiplexing. That is also one of the example how we messages is combined. See here, there are the different message. It's passed through a low pass filter. Then it's this commutator combine this message, and it is the pulse modulator modulate it. Then this communication channel transfer this. They here the demodulated, and then again it is a decommutator. This transfer this message 1 to the message output 1, message 2 to the message output 2, and vice versa. Basically, this depends upon whether this message 1 is delivered to the message 1 or message 1 is delivered to the message 3. Accordingly, its whole system is synchronized. So these are the basically way of time division multiplexing techniques. So that's all about the time division multiplexing. Thanks for your kind attention.